2, exercise 4, this one?
Yeah.
Okay, so let's take a look at this first. Excuse me. Okay, it says f of x is 1 over x plus 1, g of x is x squared plus x. Find f of g of x, or f of x times g of x. Okay, that's a multiplication symbol, right? The colored in dot. So let's see if I have enough room here. D. So this is going to equal 1 over x plus 1 times x squared plus x. So that's just going to equal x squared plus x over x plus 1. Whoops. Now, this would be unsimplified. Could I simplify this function anyway?
No.
There's a common factor, right? Wouldn't it be x plus 1 over x plus 1? Now, I just don't know if they showed the simplified form in the back or not. 4.2, I think they did, right? 4.2 number 4? Yeah, okay. So then this would simplify common factor, so this just simplifies to x. Right? All right, let's do a little review. This is not only review, but it's going to be helpful when we do the next, after composite functions, we start talking about graphing. And that means you have to be able to graph the composition or the addition of a function or subtraction or division of a function. So what would this one graph like? What would the graph look like? Just throw out some answers. This is my final f of x times g of x. Yeah, it's a linear. Anything else about it, Carl? Are there any non-permissibles? I think there is, right? X can't equal -1. And because it's a common factor, linear with a whole, at x equals -1, right? And what would the y coordinate be? Well, I guess it would be, or just substitute, it would be, y is -1 as well, right? Because the y value would equal the simplified function. If x is -1, I guess y equals -1. Okay, oops. Okay. It was probably just the simplification at the end, D, right? That you didn't realize that it was, they canceled? Yeah. Anything else that came to mind? How many people completed the homework? The add, subtract, multiply, and divide. Good. Any questions, Ibby? No? All right, are you guys ready to move on? Composite functions. These are the fun ones. So we're going to redo these examples, not looking at the answers. Then I got a couple to add to here, just sort of harder ones. The composite function, it's math. It's a math procedure, but it's not one of the 4 main operators, right? It's basically we're finding the value of a function. We clear the middle function. We work inside out, and then we find the value of the outer function. So a composite function is a combination of 2 functions, just like before, where you apply the first function and get an answer, then fill that answer into the second function. So the symbolism that we use is like a nested, it's like double brackets. So the composition of 2 functions f and g is shown as f of g of x, or sometimes, and usually we don't use square brackets. It usually looks more like this. This is how I'm going to write it. Okay, so g of x inside, and then another set of brackets. So this is f of g of x, and that's how we read it. Or sometimes shown as, okay, be careful about this. They make a big deal of it. Sometimes they don't use the double set of brackets, but they use an open circle. Raised circle is shown between the 2 functions. Just this last sentence here, be careful. Remember that the closed circle, the closed dot means multiply, and the open dot is the composite, right? These are different. Closed is multiply, this is composite. So this means multiply, and this is the composite. And once again, just like I said, work inside out. Okay, so you do your inside function first, then your outside. It's just like doing 2 questions in one, really. So let's take a look at these examples, and we're not going to look at the answers. We're going to do it our own way. So you always have to be given the functions, right? The function statements. F of x is 3x minus 1. G of x is 2x squared. So we have a linear and a quadratic. Now, it might be hard to figure out. Like if I was adding 2 linear functions, you know your answer is going to be a linear. If you're adding a quadratic and a linear, pretty much your answer is going to be quadratic. It's hard to know what we end up with here, but I'm going to say it looks like we might end up with a quadratic. So let's see. Find f of g at 2. All right. Well, first I'd find the value of the function g at 2. So g at 2 equals 2 times 2 squared. Agreed?
Yeah.
All right, so that will equal 2 times 4 is 8. Okay? Now find, so first we find g at 2. Now, excuse me, find f at, so we've already replaced g at 2 with the 8. So now we're just finding f at 8. F at 8 will equal 3 times 8 minus 1, or 23. That's it. So you're just finding function values twice. Questions? All right, what about f of g at negative 3? Okay, give that one a try. Okay, what do we have here? Anyone, do you know the answer that they got a 53?
Yes.
Okay, so g at negative 3, that's the first thing. I work inside out. That will be 2 times negative 3 squared, which is 2 times 9 is 18. And now f at 18, 3 times 18 minus 1, 54 minus 1, 53. Perfect. All right. So, the next set of questions is, or the next example is just to show you that the order matters. Order doesn't matter in multiplication or division. We know that. Meaning, 2 times 3 is 6. 3 times 2 is 6. So we say multiplication is commutative. Not that you have to know this word. Basically, it means order doesn't matter.
I have a question.
Yeah.
Why is that different from the previous equation? Previous one. The first one we substitute the 18 to x fx, but the second one is different.
Well, we use different numbers, right?
Yes.
Here we use 2 and 8. Here we use negative 3 and 18.
Yeah, but we can substitute g GF, like an AT directly to the FX.
Are you talking about numbers?
Yeah, yeah.
Okay, well, it told me to substitute 2 in for G, so I did. Once I substituted that, I got an 8. I had to substitute the 8 in.
Yeah, but think about right now.
Here, I put a
we
negative
substitute-
3 in, and I got an 18. Then I have to put the 18 in here.
Okay. But the example doesn't show that. Okay, we do the short way, right?
Well, this is basically, they did it right here,
Oh,
right? Like that way?
okay, got it.
So let's, so what I was saying is multiplication and addition are, order doesn't matter, right? 2 plus 3 is 5, 3 plus 2 is 5. But addition, subtraction and division, order does matter. So you gotta be careful, you can't just assume that, one way is gonna equal the other way, because 2 minus 3 does not equal 3 minus 2, right?
Yeah.
Also, 3 divided by 2 is 1.5. 2 divided by 3, 0.66 repeating, right? So order matters. Same as composite functions. F of g of x does not equal g of f of x. Okay, and that's the next example we're going to show. So like if it's f of g of x, it's going to be a completely different answer from f of g of x. And we'll prove that right here. So we still have our same functions. It's still f of x is 3x minus 1, g of x is 2x squared. So find f at 2 first. So f at 2 is going to be equal to 3 times 2 minus 1, which will be 5. And now g at 5 is going to be equal to 2 times 5 squared, which is 50. Okay? Now let's do it the other way around. I'm just going to do this. Now we're going to try f at g at 2. I'm going to switch things, right? So find g at 2 first. G at 2 is equal to 2 times 2 squared, which is 2 times 4, which is 8. And I think we did this one up here, right? F at 8 equals 3 times 8 minus 1, 23, right? So you can see 23 does not equal 50. And all we did was switch the order of the f and the g. So basically just demonstrating that it's a trickier one. It's kind of like substitution division. Order matters. It's very precise. Right? Yep.
Does order matter if you start from left to right?
Well, when we get a math statement, yeah, just like in when we read English in North America, we read left to right, and that's how you have to do your math. You read it f of g of x, but the way composite functions work, you work the inside first. Even though I say f of g of x, we do the g of x first, then the f. Here we do the inside f of x first, then the g. You work inside out. And I think I highlighted that up here, John. Right up here, maybe highlight this. Work the inside function first. Okay. Okay, I have one more little example to give you that's not included here. So let's try this one. If you have room on your book, you can do it. But how about try something like this? If I give you, so I'm going to say example 3, I guess. What if I give you f of x equals x plus 1, g of x equals x squared minus 3. Okay, so you have a linear and a quadratic. And this is all I'm giving you. find f of g of x and find g of f of x. Okay? So I'm not giving you values to work with. You're not going to come up with a numerical value answer. You're going to have an expression, right? It's going to be left with, you're just finding another equation. Or not equation, but expression in terms of x's and numbers. You done, Carl? Okay. What's f of g of x? What'd you get? X squared? F of g of x? X squared minus 2, is that what I heard?
Minus 3.
Minus 3? Okay. Minus 2? X squared minus 2? All right, let's see what it is. That's your final answer? Okay, let's see. I haven't done this one yet. So first I replace the inside, and g of x, there's nothing more I can do. G of x is just x squared minus 3, right? So this is gonna be f of x squared minus 3, right? I just replaced g of x with its statement. Okay, so now what f is telling me to do is f of x is saying whatever x is, I add 1. Okay, so this is saying this is my new x, I guess.
Yeah, X
So I take whatever's in the brackets and I add 1. So that's going to give me x squared minus 2. Okay, so x squared minus 2 is the correct answer. Whoever had that, you are correct. Okay, let's try the other way around. Have we done the other way around?
No.
What did you get, Neville? Want to share?
X squared plus 2x minus 2
G of f of x squared.
plus 2x minus 2.
Anyone get that as well? Yeah? Okay, so let's see. It's completely different, right? So first I replace the middle with f of x. So now I'm looking for g of x plus 1. This one's slightly harder, right? Because it involves a squaring. So now my g instructions are whatever's in the brackets gets squared, and then I subtract 3. So whatever's in the brackets gets squared, and then I subtract 3. Okay, you can't leave it like this, you have to simplify. So this will give me an x squared plus 2x plus 1 minus 3, which finally gives me my x squared plus 2x minus 2, which is what Neville said it was. Perfect, right? They're a little, do you find them a little harder to do with just the expressions than if you're using whole numbers? Because you always have to carry forward these, the variables, right? It gets a little more complicated, I think. Okay, any questions at all on this? No? All right, I'm going to give you a bit of time. I don't know how far we'll get today. It seems like you guys are catching on. This is, compared to other units, pretty straightforward, would you say, so far? Okay, so I'm going to give you time to work on exercise 4.3 on page 139, and we might begin graphing. We're going to see. We might begin the graphing part today too. And then tomorrow I'm going to bring out that examples workbook and we'll work through that as well. Okay, so it goes 1 to 4, so see how far you get. Come and see me if you need help. I'll give you some work time, and then maybe we'll reassess just before you guys go to break. Yeah, I'll be right there, Jack. we might move on to some graphing today.